Hi, I'm Ms. Hall, and this is Lesson 94, Design an Experiment. We'll begin by describing experiments. In a controlled experiment, two groups are studied under identical conditions with the exception of one variable. The group under ordinary conditions that is subjected to no treatment is the control group. The group that is subjected to the treatment is the treatment group. Randomization is a process of randomly assigning subjects to different treatment groups. In a randomized comparative experiment, subjects are randomly assigned to the control group or the treatment group. In some cases, subjects in the control group are given a placebo, which is a harmless, unmedicated treatment that resembles the actual treatment. The comparison of the control group and the treatment group makes it possible to determine any effects of the treatment. Randomization minimizes bias and produces groups of individuals who are theoretically similar in all ways before the treatment is applied. Conclusions drawn from an experiment that is not a randomized comparative experiment may not be valid. Example 1. Determine whether each study is a randomized comparative experiment. If it is, describe the treatment group, and the control group. If it is not, explain why not and discuss whether the conclusions drawn from the study are valid. A. Health Watch. Vitamin C lowers cholesterol. At a health clinic, patients were given the choice of whether to take a dietary supplement of 500 milligrams of vitamin C each day. 50 patients who took the supplement were monitored for 1 year, as were 50 patients who did not take the supplement. At the end of 1 year, patients who took the supplement had 15% lower cholesterol levels than patients in the other group. This is not a randomized comparative experiment. Patients were given a choice of whether to take the dietary supplement. No, in a randomized comparative experiment, the individuals are assigned to either the control or the treatment. They don't get to self-select what group they go to. That makes the conclusions invalid. Perhaps those people that are more likely to take a vitamin C supplement every day, they might lead a healthier lifestyle or care more about their health. So this is not a randomized comparative experiment. Now B, supermarket checkout. Checkout even faster. To test the new design of its self-checkout, a grocer gathered 142 customers and randomly divided them into two groups. One group used the new self-checkout and one group used the old self-checkout to buy the same groceries. Users of the new self-checkout were able to complete their purchases 16% faster. This is a randomized comparative experiment. So yes, it is. Then we need to identify the treatment. And the treatment is the use of the new self-checkout. And the treatment group are the people assigned to use the new self-checkout. Checkout. And then the control group. So I have the treatment group, the control group are people who use the old self-checkout. People who use the old self-checkout. Right? So these people didn't decide what group they wanted to do. They were randomly picked to be one of the groups, and you had a control group that didn't receive the treatment and the treatment group that did, which was the new self-checkout. On to observational studies. You have already learned about random sampling and its usefulness in surveys. Randomization applies to experiments and observational studies as shown below. Experiment. Individuals are assigned at random to the treatment group or the control group. For an observational study, when possible, random samples can be selected for the groups being studied. Good experiments and observational studies are designed to compare data from two or more groups and to show any relationship between the variables. Only a well-designed experiment, however, can determine a cause and effect relationship. A core concept, comparative studies and causality. A rigorous randomized comparative experiment by eliminating sources of variation other than the control variable can make valid cause and effect conclusions possible. An observational study can identify correlation between variables, but not causality. Variables other than what is being measured may be affecting the results. Example 2. Explain whether the following research topic is best investigated through an experiment or an observational study. Then describe the design of the experiment or observational study. You want to know whether vigorous exercise in older people results in a longer life. Okay, so the treatment vigorous exercise is not possible for those people who are already unhealthy. So it is not ethical to assign individuals to a control or treatment group. That's why we're going to use an observational study. We're going to use an observational study. We're going to randomly choose one group of individuals who already exercise vigorously, then randomly choose one group of individuals who do not exercise vigorously. We're going to monitor the ages of the individuals in both groups at regular intervals. And note, because we are using an observational study, you should be able to identify a correlation if one affects the other. So vigorous exercise affects a longer life. But not a causality. We can't say that one causes the other. We could just say that they are related, perhaps, depending on what the study shows.